So welcome to the next episode of this Pune Tech community on the topic harnessing the power of natural language processing and the real-time use cases in action. So this is about me. So I'm a Janarthanan Selvaraj. I'm a technical manager, senior specialist at Evident. So I'm Microsoft certified trainer as well as a global speaker for the Azure related events. And I'm an author, blogger, researcher, and I'm open source contributor. So currently I'm holding 15 multi-cloud certifications. And this is my LinkedIn QR code. If you want to connect in terms of this Azure or else any AI related stuff, always feel free to reach out to me on LinkedIn. And you can scan my QR code about in the LinkedIn page. So let's see about the today's agenda. So the actual agenda of today is the usage of NLP. What are the steps of NLP and what are the applications of NLP? And there are models beyond this NLP called as bag of words model, the term frequency as well as inverse document frequency model. And we will see one use case implementation end to end with the help of the sentiment analysis for the restaurant reviews data set. The first one is the natural language processing. What is the natural language processing? How this natural language processing has been evolved in the earlier days as well as in today's world also. This natural language processing, it is one of the sub branch of your computer science where all your generative AI as well as your large language model, those are the niche areas your natural language processing has been evolved over the period of time. And what you're able to develop your applications in your natural language processing, it is more easy to communicate to the human languages where you may able to build the applications around the natural language processing as well as the large language model and using your generative AI. This will be one of the feeding factor of those new era of artificial intelligence. And what is the library as part of this natural language processing, which is there in the Python, which is called as NLTK. This NLTK, which is nothing but natural language processing toolkit. This library we need to use in order to build any applications around natural language processing. So there are few steps you have to follow whenever you use natural language processing. First, we will use to call it as tokenization. The second step, which is your stop word. Third one is stemming, lemmatization, parts of speech. The last one is named entity recognition. So these are the steps we used to follow as part of the natural language processing as concern. When I say tokenization, your entire document can be divided into two parts. One, it could be your sentence tokenizer. The other one will be your word tokenizer. If you want to separate your document into sentences, make use of sentence tokenizer. If you want to separate your document into words, you can make use of word tokenizer. And when I say stop words are nothing but the conjunction words like all articles, preposition, those are nothing but the stop word. And when it comes to the stemming and lemmatization, stemming, if I want to remove any ing format for any of the word, which is nothing but the gerund, which is your stemming, and the lemmatization, the output of this lemmatization, which is an actual word. But when you go for stemming, you are not getting the root form. That's what most of the time we will not use stemming. But in terms of when you process any machine learning model, stemming will give more accuracy when you compare to the lemmatization. But if you are more specific in terms of words, then you can go for the lemmatization because lemmatization, the output of the lemmatization is an actual word. The last two, which is your parts of speech tag. your parts of speech tag, it could be a noun, it could be a subject, it could be a verb, or it could be adjective. All parts of speech of tag is available in your POS tag. And the last, named entity recognition, you'll be using like a famous personalities, the entities like famous personality, famous landmarks, your geolocation, those things comes under a part of your named entity recognition. So with this, we can use this natural language processing in terms of application. In terms of application, you can make use in sentiment analysis, or you can make use of your opinion mining, like which election party will win, or else which product is a good or not. All the feedback review analysis you can make in terms of opinion mining, and you may able to translate multiple languages. That is also one of the application of natural language processing. And all conversational artificial intelligence chatbot, which is one of the best example for your natural language processing, and all your virtual assistants, smart assistants, your large language model, generative AI, those are the wider applications of your natural language processing. So let's have a look in terms of the code approach. So as I told earlier, we will be importing the package called as NLTK package. And NLTK is a package and the sub-package is tokenized as a sub-package. And I'm importing the class called as sent underscore tokenize, which is called a sentence tokenizer. So here I have given some input. Okay. So this input is going to convert into your sentences. Okay. So whatever the input I have taken, if I use sentence tokenize, the complete document will be divided into sentence underscore tokenizer. The same input, if you apply for a word tokenizer, instead of sent underscore tokenize, what is the class I have replaced here is word underscore tokenize. So each and every token, like this word hello is one token, Vikram is one token, comma, special characters is also considered as a separate token, which is called as word tokenize. So as I mentioned earlier, in the stop words of English, like articles, preposition, those are nothing but stop words. And all the stop words, if I want to display in the English language, that will be stored inside one of the method called as corpus method. Corpus is one of the class where you may be able to see all types of your stop words which are present in your English language. So let's see how this is going to be demonstrated. So this is the Azure portal I'm using. In the Azure portal, I'm going to create one machine learning service. Just type that service Azure Machine Learning. Just create a workspace for this machine learning. And I have chosen a subscription already. And we need one resource group. So I'm creating a new resource group. I'm creating the resource group as test RG. So I have to provide one workspace name. I'm giving a retail workspace 2605. This is my workspace name. And you can choose any one of the region. And we have to give the storage account name, the key wallet, container registry. I don't have any data from my container, so I'm specifying it as a none. So that's it. Then hit the button review plus create. So this particular Azure Machine Learning resource in a minute or two, this is going to become successful. Once it is successful, we will be able to launch the Azure Machine Learning Studio. So you are getting the messages validation passed. Just click the button create. So in a minute or two, this is going to become successful. And you can see the deployment is in progress now. That is the status of this Azure Machine Learning service. So meanwhile time, any questions? Any questions, guys?
No, nothing in the chat window.
Okay. Let's see whether it is done or not. Yes, the deployment is completed now. So once the deployment is completed, we have to click the button Go to Resource. Here you can see there is an option called as Launch Studio. Just click the Launch Studio. So for any Python file you want to execute in your Azure Machine Learning, you are supposed to create one compute cluster. Without compute cluster, you may not able to execute any Python code inside the Azure Machine Learning Studio. The first and foremost thing what I'm going to create, I'm going to create a compute. Just click the compute. Create a compute instance. So I'll be providing the compute instance name. Just a second. I'm providing the compute instance name as retail CS 2605. And you can choose the virtual machine type. I'm choosing the virtual machine type as CPU. The other important note, if you notice that, what type of virtual machines size you want. Okay, whether you want a general purpose or as a central purpose or a compute purpose or a memory optimized, what type of category you want to choose. So I'll be choosing the category as memory optimized because that is a lightweight one. So I chosen the option standard DS11V2, which is a lightweight one, and the category is memory or optimized. Just hit the button create. So this will take 2 minutes time to get succeeding that compute instance. Once it is succeeded, we may able to create a notebook here itself, and we can execute all above Python related code. And you can notice the status as the status creating here. Once this is succeeded, we can execute it. So in this one, you can notice something called as in the authoring tab, you can see there is a notebook. Just click this notebook. In the notebook, you have the structure as users and your directory. And inside that, you can upload any type of file. You can create any type of Python notebook files as well. So till that time, once your compute is done, we can still it is saying creating. If I want to create one notebook inside this editor, what it is going to happen? Let's see it. So I'm saying create a new file. I'm creating a file name as sample, and the extension is IPYNB, which is nothing but interactive Python notebook. Just to create it. So we have created a file successfully, sample.ipnyb file. If I type some print statement to check it out, let's say what it says. I'm executing this particular cell. So it says we may not able to execute any print statement or any Python related statement in this interactive Python notebook. Why? In the sense our computer is not succeeded. Still the computer is still running. Once it has got succeeded, we may able to execute this piece of code from the interactive Python notebook. Just go back to your computer again and check it out whether it is completed or not. It says still, state says still creating. So we need to wait for some time. You can notice the status compute is still creating. Let it get for some time. It is taking time. Let's move on to the code. So we discussed about sentence tokenizer, word tokenizer, stop words. So let's move on to the stemming usage. For stemming, if I want to remove any ing format, you can make use of stemming, but the output is not an actual word. Okay. So here porter stemmer is a class name and NLTK is the package and stem is a sub package. So I'm creating one object for this class called as stemmer as the object I'm creating for the porter stemmer class. So I'll be accessing that value stemmer.stem. Stem is a method and I'm passing one input word as working. So the result will be work. If I remove this ing, the result is work. Similarly, if I use the other words like increases, I suppose to expect the output as increase, but this will print the output as increase. That E will be missed here. So this is not a proper word. So that's what we will be moving to lemmatization. So in the lemmatization, the output will be a proper word. And WordNet Lammatizer is a class name. And this NLTK is again a package and stem is your sub package. For the WordNet Lammatizer, I will be creating an object called as Lammatizer. So in order to access your WordNet Lammatizer class, we will be using a method called as Lammatize. And here it will remove this S alone and you will get a proper word. So that is the usage of your lemmatization. In stemming, the output of the stemming is not a proper word, but the output of lemmatization is a proper word. So similarly, the parts of speech. So for all the words playing, so you will be checking the parts of speech, like whether if it is a verb, play is a verb. V stands for verb, N stands for noun, your A stands for adjective, R stands for adverb. So for all parts of speech, you may able to apply your lammatize method to check the result. Let's see whether it is completed. Yes. So the compute is created now. Just hit the button. If I execute this, you may able to see the result. Hello Pune Tech Community. Okay. So for this NLP package, first of all, we have to install your packages. In order to install the packages, we will be using the command called as pip install NLTK. Because all the NLTK packages we need to download it. So I have used a command called as pip install NLTK. So once the packages has been downloaded successfully, you can import NLTK. Import NLTK. Then inside this NLTK, you may have a lot of libraries available. You have to use a command called as nltk.download all. This will download all the NLTK libraries as well as packages which are present. You can see the list of packages started downloading now. So once all the packages are downloaded, we may able to use the functionalities present as part of NLTK. It is started downloading now, and you can see the result as well. All your NLTK libraries, packages, it is started downloading. We have to wait for some time. It has downloaded all the packages. Now we can go for sentence tokenizer. You can notice the sentence tokenizer result. Okay. So this hello Vikram till going well is one sentence. Today, good day, see you dude is a second sentence. So the entire document here, it is split into sentence tokenizer. Similarly, if you go for word tokenizer, so each and every word, it is going to be considered as a token, including your comma, full stops, question mark also considered as a separate token. That is called as word tokenize. You can see hello is a token, question mark is a token, comma is a token, full stop is a token. The next one is in English, you want to print all the stop words present. You can see all the stop words which is present in the English dictionary. Like all articles, preposition, those are stop words. The next is your stemming. As I told earlier, the result of your stemming is not a proper word. So work is fine. Working, the word is work. If I say increases, look at the result. It will say a wrong word. This is a wrong word result. We are not supposed to use it. So better we have to use which one is your lemmatization. If you keenly observe that the result and the output is also a proper word, you can make use of lemmatization. So you can see the result as increase. That is lemmatization. And parts of speech, whether it is a verb, noun, adverb, adjective, we can see all the parts of speech. If it is a verb, playing verb is play, noun is playing, your adjective is also playing, your adverb is also playing. That is your parts of speech. Parts of speech tag you can notice here. Look at the parts of speech tag I have written. Microsoft Build is a fantastic event. This is one of the word I have taken. So from the sentences, it is going to be divided into separate word tokens using word tokenize. From the word tokenize, it is going to split into parts of speech tag. That is POS tag. So that POS tag is from your NLTK package only. Let's see this. So Microsoft NNP, look at the parts of speech tag for Microsoft as NNP, that is noun, plural, verb, determiner, your conjunction. Okay. All these are nothing but parts of speech tags. And the next one is your chunking. Chunking meaning is if you are dividing your document into smaller chunks, that is called as chunking. So for chunking, you will be using the method as any underscore chunk. Whenever you perform chunk, you completely divide the entire document into word tokenizer using word underscore tokenize. Afterwards, you are supposed to perform the parts of speech tag. Then you apply chunk. That is the procedure of chunking. So I have given the sentence as Satyanarayana lives in Belleville, Washington with his family. This is a sentence. So from this sentence, it is going to divide into word tokenizer. And afterwards, it is going to do the parts of speech tag. From the parts of speech tag, it is going to do your chunking. So when I say chunking, it is going to say Microsoft and famous personality landmarks. Those things will be recognized as named entity recognition. So Satya Nadella is a person and is a famous personality, and the Microsoft is an organization. Your family, these and all, your personal identifiable information. Washington is one of the geolocation. So all your parts of speech tag, you may able to get it through your chunking part. And the named entity recognition, how it is operated in the sense, first you have to do your word tokenize, then you have to move on to parts of speech tag, then you will be performing the chunking part. That's how you have to do the process of named entity recognition. So I have given the statement as Microsoft CEO Satya Nadella announced Microsoft build features at Seattle. The Seattle is a famous locality. Your Microsoft is an organization and is a famous personality. All those are nothing but named entity recognition. For named entity recognition, it is going to operate on the top of word tokenize. From word tokenize, it will be sending to a parts of speech tag. From parts of speech tag, it is sent to the natural named entity chunking process. So all we are seeing as of now, the usage and the piece of code. So how to wrap it together and into a one particular use case. Okay. I want to make one particular use case from all these concepts as one single model. So one of the famous model in the machine learning we used to call it as bag of words model. The bag of words model says that if you have a data set which contains only a string data set, then obviously you can make use of the model could be either bag of words model or term frequency inverse document frequency model. So in that model, what will happen is when you go for your bag of speech or else this models, there is a process is available. So here I have taken two input sentences. One is today is a great day and today is a sunny day. These two are the sentences. So in order to perform a bag of words model, you will be following some set of process like you start cleaning the data. When I say start cleaning the data, all your upper cases, lower cases, your comma, full stop, you remove all comma, full stop, exclamatory mark, and all your upper cases will be converted into lower cases. Those things you will do, and you will perform tokenization. You will remove all the stop words and you will start building the vocabulary of the words. Okay, so when you do that, whenever the frequently appeared word is coming, you will give the count as 1, and those are not appeared, you will give the count as 0. That's how we used to form a document matrix, which means you will be converting the entire list into an array format that is called as vectorization. There is a technique in machine learning called as vectorization, which means all your string value will be converted into a vectors, which is nothing but a numerical format that is called as vectorization. Because whenever I want to train any machine learning model, I should not use any numeric, I should not use any string values. I have to convert all my string values into numerical format that is called as vectorization. If the word has appeared in the document, you will give the count as 1. If the word has not appeared, you will give the count as 0. With this, which helps to form your document matrix. But what is the drawback of this bag of words model is all your words will have the same importance. The value could be either 1 or the value could be 0. You will not get a precise result when you go for your bag of words model. That's what we will be moving for the model called as term frequency inverse document frequency model. So this is called as term frequency inverse document frequency model. So for the term frequency, how will you calculate the term frequency formula is frequency of a word within the document is called as term frequency. And the meaning of inverse document frequency meaning is frequency of word across document is called as inverse document frequency. Using this model, every word will have its own importance and every word will have a proper numerical value. It is not like 1 or 0. It could be 0 0.2, 0 0.3, 0 0.4, like an exact accurate value will be getting when you use term frequency inverse document frequency model. So for this, we are going to discuss one of the data set called the sentiment analysis use case data set. So whether it is a positive sentiment, negative sentiment, or neutral sentiment. So for this, I have taken one of the data set, which is the restaurant review data set. So this is a restaurant review data set, and this particular data set, which is an unstructured data set. It is not a proper structure. If you notice that this structure is not in a proper format. And here you have to identify the first the independent as well as dependent variable in your data set as given to you. The moment the data set is given to you, you will be noticing there are two columns present. One column is a review column. The other column is nothing but the liked column. And here the dependent variable y, which is a dependent variable y in the sense liked is nothing but the dependent variable. And your x, which is your review, is an independent variable. And in the dependent variable column, you have two values only. It could be a binary values. It could be 1 or it could be 0. Okay. And if you notice this complete thing, it is not in a proper format. We have to start cleaning this one. In order to do cleaning process, we will be using data wrangling as a technique. So when I say data wrangling technique, you remove all full stop, comma, exclamatory mark, special characters, and convert all your upper cases into lower cases technique. Then you filter out it, which are the words which are having less importance, you filter out, and which of the words which is most frequently occurred, you consider those word and you form a document matrix. So that is a technique behind this particular data set. So for this data set, I have written the code in the um, Python code. And what is the model we are going to build in the sense? We are going to build one of the model called as Navy-based classification. Under Navy-based classification, actual model name is called as multi-nominal NB. Multi-nominal NB is one of the Navy-based classifier subcategories. So this model only we are going to predict because the entire data set is in terms of string values. Look at the first line. We will be importing the package called as pandas package because all our data set is in the form of data frame. So this is a data set we need to import to our machine learning, Azure Machine Learning. Let's import it. I just upload the file. Just upload the file name as reviews.csv. Upload it. Once the file is uploaded, you may able to use a pandas library, import pandas as PD. The second one is you will be reading that CSV file with the help of the method called as read underscore CSV. And what is the name of the CSV file? Reviews.csv. It is not in a proper format. We want to make it in a proper format. Then there is an attribute called as encoding attribute. In the encoding attribute, you are making the document in a proper encoding format. Because it is unstructured data, you are making it as a structured format. That is the usage of encoding. And separator, I want to make it as tab separator, which is a /t. And you have to mention the column names in the names list. So there are two columns are there. One is a review column. The other column says it is a liked column. So that's it. This is a way to read the data set. Once the data set is read, you can able to print it. So here you can notice something called as NaN/T0. It is not in a proper aligned way. So we will be using the NLTK package to align it properly. For that, you are using the regular expression RE package, NLTK package, and the subpackage is corpus to remove all the stop words. And POTA stemma class you are using because you want to get the accuracy score as a part of a matrix. So our POTA stemma class object is PS, and I'm creating a list is called as corpus as a list. And it is not a single word or it is not a single sentences because it has a huge number of rows. So I want to iterate through a for loop for I in range. Range is a function 0, comma length of the data frame. So you are creating one local variable called review. Review is equal to re.sub. Sub meaning is you are substituting that values. So what is the format I'm substituting is other than capital A to Z, small t A to Z, you are substituting with a space. Okay, for the entire column, review column. And how many times it is going to exist based upon the length. After you are done that, removing all the special characters, comma, full stop, question marks, you are lowering the complete document using lower method. And once you are lowered it, again, that entire result you will be storing in the review. Once it is done, you will move back to your split method to split into the words format with the help of split. And this is called as nothing but your list comprehension. In this list comprehension, I am performing two activities. One activity called as stemming activity. The other activity is called as removal of stop words. So what I'm doing, the removal of stop words in the sense, if the word which is not present in the part of English corpus dictionary, wherever the stop words are there, just remove it and you will be performing for the word as into stemming format. Once it is done, the entire value will be stored in the review. Then you will be joining with the help of join method to review that words. Afterwards, you will be appending the entire list to the corpus dictionary, and the corpus is nothing but a list variable. So up to this step is called as data wrangling step. Once the data wrangling is completed, we want to convert all the string values into a numerical values, that is called as vectorization. For any vectorization, we will be using the class name called as TF-IDF vectorizer. This is called as term frequency inverse document frequency vectorizer is a class name, which is a part of your feature extraction text module. Okay. And what is the object I'm creating for TF-IDF vectorizer is CV is the object I'm creating, and X is your independent variable. So CV dot fit underscore transform, because we have a corpus list. That corpus list is converted into an array format, which is called as document matrix. So that is your X. And Y is again your dependent variable, which is your numerical format. So in order to convert a numerical format 1 or 0, you will be using the method called as get underscore dummies. This get underscore dummies is a part of your pandas library. And the usage of ILOC meaning is you are using the index position values. That is your ILOC. And LOC meaning is your column names. That is your index column name, and ILOC your column position. So till X and Y you're able to find it, then you will be moving for the machine learning model building. So let's execute this code up to this, then you'll get clarity. If I print X, will you able to see the X value? It is in which format is matrix format. That name of the matrix is called as document matrix. So you'll be getting the exact value. It is not like 1, 0. It will be 0 0.2, 0 0.3, 0 0.4, 0 0.112. Like that exact value you'll be getting when you go for your TF-IDF vectorizer. Similarly, when you go for this Y, you will be getting that a binary value. It could be 1 or 0, or it could be true or false for all the entire data set. So once this is ready, you may able to build the model. So whenever you want to build any model, you want to split your data set into training data set, test data set. For that, you will be using a class called as train underscore test underscore split. In that, you have to pass X value, Y value. Your testing data set ratio is 30% I'm passing. So I'll be using this. So train test split is done. After it is done, I'll be building the model. What is the model I'm going to use, or what is the algorithm here is multi-nominal navy-based classifier. For the multi-nominal navy-based classifier, there is a method called as fit method. Inside the fit method, you will be passing your X train values as well as Y train values. Afterwards, you will be using the predict method to predict the model with the help of X test. So you'll be getting a numerical values and you go for Y prediction. That is true or false. Then, so these three are the important matrices for any supervised learning algorithms, especially for classification technique. So what are the matrices you have to use? One is classification report, confusion matrix, accuracy score. For all these matrices, we have to pass the input as your Y test. Y test is nothing but actual Y. Y pred is nothing but your predicted Y. Let's execute this. We'll get the result. So you can notice the result as 99.6% accuracy score, which has been got for the restaurant review data set, which is pretty much good when you go for your any type of classification based model under your supervised learning. So likewise, you can build any type of model with the help of this natural language processing. It could be your detecting ham classifier, spam classifier, restaurant review data set, your feedback, your employee survey, sentiment analysis, opinion mining, text classification, text summarization. These are the use cases, and even your all conversational AI chatbot also you're able to build with the help of the machine learning model. So those are real-time cases where NLP has evolved over the years. And we got the accuracy score as 99.6% is accuracy score. You have the confusion matrix, and there's a classification report for any supervised learning, especially the classification type of algorithms. So that's it.